Hello, and welcome to our webinar, 5 Minutes to 50% More Attack Surface. My name is Lauren Craigie. I'm from BugCrowd, and I'm here with Casey Ellis from BugCrowd as well, and Jeremiah Grossman from BitDiscovery. We are so thankful that you guys have joined us. This carved out some time in your day. We're going to keep this pretty tight, just to be considerate of competing schedules. So without further ado, I'd love to pass it over to Casey.
G'day everyone, thank you for joining us. My name's Casey Ellis. I'm the founder, chairman and CTO of BugCrowd. Been in the security industry for about 20 years and doing BugCrowd for the past 8. Really the focus and the catalyst for starting the company was this idea of the need for human creativity to augment what's already available in automation. Security is a fundamentally human problem. Automation is incredible because it doesn't need to sleep, but there's still that creative element that's required, and that's a lot of what we're going to be talking about today. But I'll pass it off to our other guest on this webinar, Mr. Jeremiah Grossman.
Thanks, Casey. Good to be with everybody. Thanks for taking the time with us. Casey, great as always, co-hosting a webinar with you. For those
Absolutely.
that don't know my background, I've been in information security for about the same time as Casey has, about 20 years. Before founding BitDiscovery, I was the founder of White Hat Security. So my background is a lot about finding vulnerabilities. And after working with hundreds and thousands of companies over a long period of time, I felt the #1 problem that had to be solved, the biggest and most important unsolved problem, was asset inventory. We should really know what it is that we're protecting so we could secure it. Just one of those novel ideas. So I founded a company around solving that particular issue, and I'm happy to share with you and along with Casey what we're working on.
It's 11 p.m. Do you know where your internet-facing assets are? What we'll be going through today, our agenda, introduction, like why are we here, what are we talking about, what's the nature of the problem. We'll be looking at some of the data, particularly the data that's come out of BitDiscovery and the work that Jeremiah has been doing, but also some stuff that BugCrowd's contributed to as well. We'll get a demo of asset inventory in action, understand a little bit of how it works and how this kind of man and machine interface that we've put together with the suite of products, what that looks like for the user. And then, really end it with some quick tips on how to get started with this idea of getting a handle on your attack graph for companies of any size and stage. Like I think Jer and I both agree that this issue of sprawl, attack surface sprawl, is something that affects young, small, nimble companies as much as it affects the larger, older ones. So we're going to drop you with some tips at the end there, and we'll have some Q&A. What we've also got is an offer which will basically explain at the end of the webinar, free attack surface analysis. So stay tuned after the webinar or at the end of the webinar, just before the Q&A, and we'll provide an access code and access details for that.
Let's jump into this one here. Most everyone, especially if you're on the webinar here today, is familiar with the Equifax breach. What a lot of people missed about the Equifax breach, or what they got from it, is that Equifax, there was a vulnerability out there, one in Apache Struts. It was well known. A patch was available, and Equifax didn't patch against the vulnerability. They were compromised, and hundreds of millions of people's data went missing. One of the interesting things that you find is in the Federal Trade Commission complaint, the FTC versus Equifax, and in the pages, that yes, there was an unpatched a vulnerability that Equifax knew or should have known about. In fact, that they did know about, but they just didn't patch that server. The background story is, if you read the pages, is that they actually patched that vulnerability on many of their other systems, just not the one that was compromised, because if you read it here, they did not maintain an accurate inventory of all public-facing technologies that were running Apache Struts. The concept here is, if they had an up-to-date or accurate inventory, they probably would have patched that system, and we wouldn't be talking about this, and this would not be a story. So that's the part that we want to spare everyone else from, is helping them not get hacked from a system that they didn't even know they owned. How's that sound, Casey?
Absolutely. Yeah, no, I think it's an interesting, because Equifax has been breach case study du jour for quite a while now. I think this particular aspect of it is fascinating, in that there was vulnerability management programs, there was patching programs, there were, all of the different things that a security team needed to do to potentially resolve this vulnerability were actually in place and were actually, implemented ahead of when the attackers came along. They just missed the box that they happened to use to get in because they didn't know it was there. And the fact that that kill chain and that conversation actually made its way into the FTC complaint is a pretty compelling reason, and I think a pretty compelling marker for everyone else to realize that this could happen to them, and it's something they should probably get ahead of.
So when a adversary or even a pen tester looks at a target, looks at a company that they want to break into, there is a series of steps that they must go through in order to achieve their goal. And most of the conversations that we have in information security are about vulnerabilities and exploits and command and control. And while there is some conversation about the reconnaissance, the first 3 steps, this is the part that we fall down as an industry that we need to improve upon. So before you attack a target, whether you're an adversary or a pen tester, you have to do reconnaissance. What boxes do they have out there? What services are running, and what might they be vulnerable to? That reconnaissance, those first 3 steps of recon, finding a place you're vulnerable, the weaponization, I should say, and delivery. Those are the 3 steps where I think we're the weakest and where we're going to spend all of our time focusing on.
Yeah, and it's interesting. One of the reasons that Bugcrowd really started moving towards doing this a couple of years back is that we actually observed the bounty hunters triangulating on this phenomena. The fact that I think because of a combination of like legacy IT, like assets that you acquired into your organization or otherwise took possession of that you forgot to switch off, and I think more recently this kind of phenomena of shadow IT and the engineering team or the marketing team with a credit card. This is a pretty broad problem, and what we found, because particularly in the context of a public bug bounty program, the incentive is for people to find things first and for them to create or identify as severe an impact as they possibly can in order to maximize their payout. What that did was it encouraged bounty hunters to basically go looking in places that other people wouldn't, and sure enough, there was a lot to be found. So this phenomena of bounty hunters like really focusing up on recon and actually being quite successful out of that to us was very interesting from the view of the other products that we have, but also it kind of pointed out the systemic issue of the fact that what Jeremiah just said is true. We're actually not very good at this first part. There's automation and there's techniques and systems out there that are tasked with maintaining inventory and trying to find new things, but the challenge is that humans build computers, humans create these systems. We're all unique in how we approach the application of our creativity, and every business is unique. At the same time, computers only know how to do what they've been told to do. So that leaves a gap, which as it turns out is actually quite a large one.
Yeah, one of the things, Casey, I wanted you to comment on, because I heard from some bounty hunters that the top bounty hunters are the top bounty hunters, not because they're the best at finding vulnerabilities, because they're the best at finding systems that no one else could find. How true is that really?
Yeah, it's very true. I don't think it's I wouldn't say it has 100% coverage of the people that are top by way of payouts, but it's definitely it had passed the 80-20 rule for sure. I think it continues to be a really big issue. I think particularly in kind of the earlier days, like when you hear about total payout numbers for bounty hunters, they tend to be all time, and these are folks that got in typically fairly early in the process and really were executing on finding bounties from unknown assets without a whole lot of competition in the space, and they made a ton of money doing that. So yeah, there's definitely a trend. I think the cool thing is that how do we actually give them support? How do we give them access to more automation and more data to be able to then go on at the behest of the customer to figure out the actual risk of these systems that have been identified that might not have been known before. All of that nets out to things being better known and able to be actioned and secured. So yeah, and this is, I mean, probably the way that I like to frame this is that there is at any given point in time, there's like almost a graph that the blue team or the defender has. There's a picture that your organization has of what its external attack surface looks like. There's the version that you've got, and then there's the version that is ultimately available to an attacker. And usually those two graphs are a very different size. The red, in this case, the bad guy attacker graph is significantly larger. And really, the objective becomes like, how do you get those two things, those two graphs, your graph and then what's available to a potential bad guy, to be roughly the same size, as close to the same as you possibly can. This information mismatch and the gap between what you know is there and what is actually there and identifiable by someone else is really where a lot of these issues pop up. Equifax is the one that Jeremiah just mentioned before. Another one that I find fascinating. It's a fairly old breach, but JP Morgan Chase had a hack, I think it was 2015 or 2016, which was traced back to a web server that was used for UAT or development and basically left switched on. It wasn't under the purview of the production security program. People basically just forgot it was there. And then a bad guy found it and went off and did a whole bunch of bad stuff with it. Those are the examples of what can happen in that gap between the defender's graph of the attack surface and what's available to the attacker. So yeah, really, we've spoken about the benefits of automation. I mean, something that I say often is that automation never sleeps, which is an advantage that it has over humans. But at the same time, humans have the advantage of creativity that's well beyond the capacity of automation. What's amazing and powerful about this partnership is the work that Jeremiah and the Bit Discovery team have done is phenomenal in the access to data and then the automation that you can apply to that data to basically provide continuous management and monitoring of your attack surface and do it in a way that doesn't sleep. Where we come in is finding the hunters that are most proficient at recon. What they'll do is they'll take the data in Bit Discovery, they'll take things that they found for themselves, and they'll do what hackers do. They follow leads, they pull threads, they find new kind of fringes of the attack surface that might not immediately be obvious to automation. So that's part of it. But then the second part is to actually use the data that we've got historically around which of these newer assets are likely to be problematic, as well as their own intuition as a bounty hunter, to actually prioritize and create risk scores for the different things that come out of that part of the process.
One of the things as we were working on this problem at Bit Discovery that, as I mentioned earlier, I've been working in the vulnerability finding space for White Hat for many years, is how similar the research is and the R&D effort is. So as we know in vulnerabilities, you can find a certain amount of vulnerabilities using automation, but there's a certain class of vulnerabilities, we generally refer to them as business logic flaws that have to have a manual review. They can only be found by humans. It's actually no different than in asset inventory. We can find a ton of assets using automation, but it's hard to know the brands and different websites and things a company owns that might be on subsidiaries. So there's always going to be room for the assets that are missed and that must be found by experts or human assistants, I should say.
Absolutely, yeah. I think automation is brilliant at creating what's ultimately a list. What the creativity component adds to it is really looking at each of those things in the list as a lead. Like you think of it. I mean, asset discovery for a human, someone who's doing this type of work, a bounty hunter or an attack surface mapping person on the platform. It's like they're a detective. They're looking for leads. A good example of what we see people do is they'll look for the favicon or the some sort of marker in any kind of web content that's served up, and then look out at other assets that they think might be connected to the organization for similarities or identical properties to the ones that they know are associated with that organization, and then follow that lead. Sometimes you can have we've had examples where 6 figures of net new assets have actually fallen out of that type of discovery process.
All right, so how do we go about gathering this data? One of the failures, that's probably too harsh of a word, but one of the challenges we had about doing asset inventory way back when is that you give the system a little bit of seed data, an IP range, a domain name, and you send it to go out to scour the internet looking for all the things that an organization owns, a process that took days, weeks, if ever, and false positive written. So if you take all those, what we did was we took all those techniques that you did for finding assets on the fly, and we ran it on the entire internet. So we gathered as much data about the internet as we possibly could, every domain name, every host name on every domain name, looked at every IP range, port scanned everything on the internet, got all Whois data, all the metadata about every asset, and we wanted to store it in a very huge database. So we wanted to gather a copy of the internet, so to speak. It's probably overstating it a little bit, but we don't need the content, but we needed everything on the internet to make the approach fast, so we could surface the slice of data, the inventory from one organization extremely quickly while we're always pulling in more information. Let's go on to step 2. Now, so after we gather all this data, what does it look like? When we show you metrics and stats coming up very soon, our data set has about 4.4 or so billion DNS entries, billion assets. Now, we think that somewhere around 70-75% of the internet based on our tests, so we're still more to find. And to find all those, we have about 400 different data sources that we're always gathering data from. We're mining the internet as best we can, but no one entity can have all the data, so we license it from other third parties too. So as I mentioned, it's Whois databases, all the ASN data, service banners, all the metadata about every single asset we can glean, we store locally. Collectively, each asset, an asset is a domain name and IP address generally, and each asset that we have has right around 115 total unique data points, metadata about each asset. Could be an open port, its service banner, things like that. Each data point on every asset we try to update at least monthly, and we're always getting faster. And all these, every time we collect data, we create snapshots, quote unquote, of the internet, and we have that stored for about 5 years back. And we think, best we can tell, it's the largest data set of its kind. So there's a lot to be learned when we mine the data and derive statistics, and that's what we get to talk about. So I'm going to describe what this chart is, how it was derived. So we took the top 10 US automakers, the top 10 US banks, education, and so on by industry. We developed an inventory for each one of those organizations and did a statistical analysis. So the way to read this is, for the top 10, for the average top 10 US automaker, the median number of assets they have that are connected externally to the internet is right around 20 to 25,000, though there isn't the hard number in there because it'll fluctuate a little bit. The education industry, the average top 10 university, on median, they have around 130,000 things exposed, connectable to on the internet.
It's a lot of things.
It's a lot of things. It's everything from it could be printers, websites, DNS servers, mail servers, VPNs, IoT light bulbs, things like that. So you can see certain industries like education and technology have more assets than others. We have theses for why this is the case, but we don't always know why certain organizations have more assets than others. Casey, maybe you have some theories on why this is the case here.
Yeah, education's a fun animal in this particular domain. Just as you were going through, it was reminding me of a story of an inventory that we did for an educational institute, and we found just tens of thousands of VoIP phones publicly connected to the internet. Okay, good to know. But sure enough, 2 or 3 weeks later, there was a couple of ODE that dropped in that same model of VoIP phones. So at that point, they were very grateful for having that information, because they actually, I don't think, had it prior to getting it from us. But yeah, what I've understood and what I believe to be the reason for the number of particularly just addressable IPs in education. Education was one of the first recipients of NetBlocks when Aaron started handing those out back in the day. So it's been fairly common practice for universities and educational institutions to basically just give everything a public IP. So instead of the traditional model where you've got block of public IP addresses, and then you've got a NAT sort of set up, and you've got your different sort of internal networks that sit behind that in terms of your corporate environment. For universities, it tends to be, let's just chuck it all on the internet and wire it together in that way. I think we'll probably see the other sectors actually start to catch up to education as cloud adoption continues to accelerate, because it all sort of ends up looking like the same thing at that point. But I think from what I've understood, this is something that's actually been a problem in network security for a really long time, and that's my understanding of its root cause.
The sobering part for me when I was looking at this data is, yes, certain industries will have more assets than others, but on any one of them, I mean, imagine if you're a top 10 automaker or a bank and you're having to look after 10, 20, 30,000 assets online. I mean, talk about a management nightmare. That's just a lot of things to make sure that they're secure all the time. So anything we do in InfoSec must scale to that load.
Yeah, absolutely.
So let's look at the next one. So this is domain names. So again, the way to read this slide is the average bank, top 10 US bank, has just under 1,000 total domain names, maybe about 800 or so. For education, that number drops way down. So for the average top 10 US university, maybe it's like 100 and 120. And we had some theories on why certain industries or the average company in certain industries have more domain names than others. The way it seems to us, and Casey might have a different theory, is that these ones, the banking, hotels, healthcare, and retail, they tend to be two things. They tend to be phished the most. So there's lots of phishing domain names that they have to pre-register and squat on. And they have a lot of brands that they wanted for the same reason, to protect the domains and the intellectual property around those domains. A lot of them don't have any quote unquote true assets. They're like placeholders. They're domain squatting for their brands.
That's interesting as a theory, and yeah, I mean that sort of thing definitely impacts those verticals more. Yeah, and another one, I think there's probably lots of things that contribute to this, and that would be one of them. Another one that we've seen, the product manager who drives attack surface management within Bugcrowd, Randy, he's spent a decent chunk of time working on techniques and pivots and different things like that. And one of the things that's been really interesting is to actually go through the different companies that have been acquired by the parent company or from the seed data set over time, but then go a second and a third level on those acquisitions. And looking at this list, the ones that have a lot of domains in there are the ones that you would consider to be more naturally acquisitive as businesses than some of the other ones. So you end up with, oh yeah, this is this company that we bought 10 years ago and we thought we switched it all off, but we didn't realize from an IT standpoint that they bought another 6 companies before we bought them. Exactly, and all that stuff's still turned on, right? So like there's those sorts of things where as you again go down the rabbit hole a little bit, you can actually find quite a bit more than what you potentially expected to find in the first place.
Let's look at a couple more. Real quickly, we can touch on these expired TLS certificates. So you can see the education space. On average, the top 10 university, or I should say on the median, I think that's the right way to say it, for the top 10 university, they have about 800 expired TLS certificates that you can publicly connect to. Automotive is similarly really high, hard to understand why. The banks have about 100 websites with expired TLS certificates are out there. You can kind of get the idea, but you can see for the average organization, even the biggest organization, it's a real challenge keeping up to date on your TLS certs.
Yeah, it's interesting that hotels seem to be doing comparatively well. Like hotels aren't necessarily known for super tidy IT security practices, but they're not doing too badly here. I think education's probably safely explained through the thousands of VoIP phones that have self-registered certificates sitting out there on the internet. I guess I mean, go ahead.
Yeah. Sorry to interrupt. I think it might have to relate to, if you have a lot more assets, then by percentage, you're going to have a lot more expired TLS certificates. So this one might be better served with a rate that, if you have fewer assets, you're going to have fewer expired certs. It would stand to reason.
So in that, Jer, we've got this listed as a question. Like, what is it from your perspective and talking to customers that makes certificate tracking difficult? Like, what is it in the way that they're handling it today that's actually making it difficult in a way that we get these sorts of numbers?
From what they tell me is, one is they just have a lot of systems
Mm.
that they don't know about, and
Yeah,
then keeping up to date on all these certs is difficult because you have to always request new certs, put them on the system, you have to track them all, and the tools around to do that, doing it is tedious, and the tracking tools are almost non-existent. So it ends up
yeah.
being an IT challenge, not an IT security challenge. It's just one of scale and tools.
Absolutely. Yeah, I mean, it comes back to the same thing of like they just don't know it's there. Um, I know for bounty hunters, expired certificates like that can be in and of itself a security impact, but even if it's not, it tends to be this kind of almost leading indicator of crappiness of a particular asset. Like if it's doing things like throwing an expired certificate, that's indicative of the fact that it's probably been neglected, which means there's probably other issues to be found on that particular asset. So it's one of those things that does tend to throw up a red flag. And when you look at the kind of vulnerabilities that tend to accompany stuff like this, it does tend to be true. Like if you've got an asset that you don't know about that also has an expired certificate on it, it's fairly safe to say that the security team hasn't looked at it for a while.
All right, so let's jump into this one a little bit. So this first 40% statistic is a little bit anecdotal. So one of the things that we do is, like we'll do for you here, is we'll show you how BitDiscovery works. But when we do that, one of the things that we like to ask whoever we're showing the demo to is, how many assets do you think you have? It's kind of a game. They might say 100, they might say 500, 1,000, 10,000, and then we
Nice.
do an actual inventory, and we just see how far off the numbers are, under, over. And from our experience, generally most organizations will have about 40% more assets than they thought they had, because very few by percentage actually have an inventory. And I believe the next two stats came from BugCrowd related.
Yeah, for sure. I like that. It's almost like the guess the number of jelly beans in the jar contest that you see at the school carnival, or that you used
But
to
at
see at
least
the
you can
school
see the
carnival.
jelly bean jar.
There'll probably be a virtual jelly bean equivalent at some point. Maybe we could do that with assets. Yeah, so the number of so we did a market study in 2019 and asked similar sorts of questions to the one that Jeremiah just asked. And yeah, 400 plus was really the average number of unprotected or unmonitored assets per organization, based on a combination of the questions that we asked and what we're able to actually do, gather from a data standpoint by running ASM and looking across them all. And the estimate from the folks that we spoke to, these are high level, like security managers and CISOs within organizations that were a part of this market study. About a third of them estimated, well, a third of the attacks that they perceived to be successful, they decided, or kind of came back that about a third of those are actually executed against those unknown assets. So there's this awareness that we were picking up that this is really kind of the dawn of the market in general, realizing that this is a problem. Like the bad guys are aware of the fact that this is an opportunity for them to execute attacks in a way that's cost effective, because when you remember that bad guys are economically rational as well, they are going to be looking for the easiest way to achieve their outcome. This tends to provide some fairly easy options for an attacker to use to complete a task. So yeah, that was some pretty interesting feedback that we got from the market in terms of how they perceive the problem, and being able to marry that back to data has been interesting as well. So how do we work together, Jer?
We work together. Yeah, sure.
Yeah.
So our part,
BitDiscovery's
part.
I know how we work together.
Well, we help the organizations out there scan and find all their inventory. We generate alerts so they can see when things change in their inventory they're interested in, maybe TLS certificate expiry, maybe when potentially vulnerable assets come up, or maybe with something like an F5 vulnerability, or they want to know anytime an F5 related asset shows up. And then we can send it over to you guys for prioritization, because we're going to send over a lot of data.
Yeah, absolutely. And I think that's where, when you're explaining the data set that you're actually sitting on, the richness of that, and I think the need to be able to query that type of data set in real time, as like Pulse VPN, ODay, or whatever else it might be that drops out, that needs to be assessed fairly quickly. That's incredibly powerful stuff. I think from our perspective, it goes back to some of the stuff I was saying earlier in the talk around the human ability to pivot off initial information. Take each asset and treat it like a lead in a detective case. Take the metadata and take things that the researchers are able to find for themselves to go deeper and actually find new sets or tranches of assets that are connected to the parent that aren't necessarily intuitive to automation, and then to be able to prioritize. I think the thing that's really important here, and one of the things that we decided pretty early on in developing this product, was that if you just drop a big phone book of net new assets on the table of someone that's tasked with IT security, you're not really helping them out all that much, because they've probably already got a lot of stuff to do, and you've just given them a lot more. So a big part of what we've called out in the product is the assessment of risk of each of the assets that are discovered, and from that, the consumer of that can actually work out how to prioritize what they need to fix.
All right, we're ready for a demo. We'll see it. We've talked enough about it. Let's see it. Let me bring up my window here. That's the one. Show this window. All right. Casey, can we see my screen?
Yes, sir.
Yes.
Sorry, I was just on mute. Yes, we can.
All right, we got the screen up. So to overly simplify, Bit Discovery works completely in the browser. There's nothing to install, no hardware, no software, nothing to configure. The vast majority, if not exclusively, the data we transact in is public internet data. We just happen to have it all in the same spot. So the use case is for any organization, yours or someone else's, you can find out what they have exposed to the internet. You can see my inventory is pre-populated with a whole bunch of different assets, in this case from Boeing, just a random company. You can see they have host names, we have the record type, IP address, and that's generally one of these rows is an asset. Some assets we'll be able to get screenshots from because they have websites, but real quickly before we go into a particular asset, how we add new things. The easiest way is just to add a domain name for the target organization. I'm just gonna pick one at random here to say NFL, since no one's playing right now. So you add the NFL domain, shows up here, and we start, because it's already pulling it out of the database, we don't necessarily have to go out and grab it because we already have it. We're gonna pull in about 1,897 different assets under NFL.com. Now, one of the things that we do is we want to find related assets. So we look, one of the techniques we use to suggest things to the user that organization also owns is we look at the Whois data for the email address registration of that domain in Whois. We take that email address and apply it to all of Whois to surface other domain names that organization owns. And you just, one click and you add all those domains into the inventory, and they'll automatically start getting added to your inventory. That's one of a set of about 4 or 5 techniques now that we have employed, that we periodically make suggestions to the user on what more things they could consider adding. Now, next is we can go into an individual asset and look at the metadata with it real quickly. We can click into one of these. You can see the metadata that we have, the record type, IP, ASN data, is it cloud hosted, so on and so forth. The services that are running on it, the port data, geolocation data, time zone, country, and all the technology stack data. It's using Varnish. Is it using some web widgets that include Google? It's programming, what programming languages is it using? As much metadata as we can give the user as possible, it's all in there. So that's what we had for each individual asset, and I'm gonna flash a screen real quick here so we can show the columns. So you can see all the different types of data that we're collecting on every different asset. The final URL, we can see CDNs and so on and so forth, and when you're done, you click OK. So since this is a very short demo, I'm going to stick to the basics. Now that you have an inventory, you want to surface certain things that you might be interested in looking at. Perhaps you're looking for the TLS certificates that have already expired in the data set. Very simple. You just create a quick filter that looks for those things, no problem. Perhaps you're looking for the ones that expire in 60 days. Those are those, really fast. Nothing goes as fast. And we'll do one more real quick. How about hosts that may not belong on the internet? Things that, you know, the host where the host name contains QA. So we'll let that pop up. Here's our potentially internal systems that are publicly accessible. So we can see those. And any of these filters that you create, you can save the filter like a smart folder in your inbox, name it, and it goes into a list. So that's the last thing I'm going to show you real quick here is I already have a list of pre-made filters, smart filters, really. So you can see maybe we're interested in things that have an open port, you know, open RDP ports. You can surface those really quickly. Maybe we're looking for, like I mentioned earlier, anything that's running F5 devices, you know, big IP. So we'll have those come up in a second. Come on, don't fail me now. The internet just got a little slow. So that's the filters. The filters here, any services that contain the string big IP, services that contain big IP, and the data should populate here in a second. If not, we'll have to skip on. There we go. So here are the things, all the assets that look like they're running F5. So you can see everything that's highlighted here. So it makes it really fast to do target acquisition on things that you're interested in. And the last thing I'll say is everything in the system is API accessible. So the whole system is very user-friendly, very easy to use to add and remove things. So simple demo.
That's awesome. And just for the sake of clarity for the audience, were you just hacking the NFL then, or?
Hacking?
And that's obviously, yeah. Were you hacking the NFL just then, or is it something different? It's a loaded question because I know the answer is no. But
no, I wasn't compromising the NFL, but I was looking like any adversary or IT professional should, what the NFL has, the organization, you know, what they own and everything about the technology stack on every asset. That's what I was doing. And then if you wanted to proceed further to pen test it, you know, look at what's what, then that's why you use filters.
Absolutely, absolutely. Yeah, I think the call out I was inferring there a little bit is, you know, not actually intruding or doing any kind of intrusive testing on these assets, actually using, you know, the phenomenal data set that you guys have to be able to create these pivots and work out, you know, what is where, and then, you know, what you need to go off and look at first based on your ability to pivot through what you've got in the platform there. Very good. So we'll talk about the reporting and the stuff that we've actually got coming out of asset risk. This is, and just to be clear, asset inventory, which is the piece that's powered by BitDiscovery, that's the part that, you know, is automated. That's what you just seen from Jeremiah. Asset risk is the part that the crowd come in and do. They stand alone, but as you can probably tell, they work very well together. You know, what you actually receive as output from asset risk is, you know, really all of the hosts that have been discovered by host and by IP address. Then what we're doing is basically putting work in to attribute each of those hosts back to the parent organization. I think the thing that's changed about asset discovery and, you know, even vulnerability management itself over the past 10 or 15 years is that, you know, the historical approaches have always operated on the assumption that you know the things that are yours and you go out and scan those things. You know, given now that we're talking about cloud as just a normal way of doing business and all of those other good things, really the question becomes like, what all on the internet is mine? That gives you a large list, and then what you want to do is be able to, you know, actually tie those kind of suspect assets back to your organization in a way that gives you high confidence that they are indeed yours. From there, we then categorize. So really what that's about is some of these leading indicators of poor quality or leading indicators of security issues that exist within the asset that we're able to identify. That list, by the way, is informed from, you know, 8 years of data that the Bugcrowd is now sitting on from bounty hunters going out and attacking systems and figuring out what are the things that that are the precursors to actual exploitability. So we're using that to inform what we believe are the highest indicators of something being likely to be vulnerable. The high risk category is just that, it's likely to be vulnerable. We have a medium risk category, which is really around, even if it's like less likely to be vulnerable than the high risk category based on the data, if it's exploited, it's likely to be impactful. So it looks like an important asset. And then the low risk is basically everything else. So really what that comes down to is this prioritization list of our perception of risk. We provide a rationale for those assessments as well, so it's not just us putting high, medium, low on things. You'll be able to actually understand how we reach that conclusion. And then from there, as a security team and as an IT organization, you'll be able to prioritize what you do next. And really, this is kind of the delta, or the difference in when these two kind of approaches start to work together. The human element, combined with automation, it's one of these things where you see this phenomenal increase as the researchers, as the people that are working on these engagements, the asset risk engagements, basically pull the threads that I was talking about before. It starts off with a seed of domains and IP addresses that the customer supplies. Like these are the known knowns and the high order kind of assets that you should be able to then infer what the rest of the environment looks like from. So your domain name, your core net blocks, that kind of thing. Asset inventory goes through the known knowns that can be derived by snaffing the entire internet, as Jeremiah has gone and built. Asset risk is when the researchers start pulling on the threads and doing some of the things that I mentioned before. The idea of a web server that you find sitting in some cloud hosting provider that has the same favicon as your main front door website, like that's fairly likely to be yours. If you can find some other things to tie it together, then you can be pretty much positive at that point that asset over in that weird place is also yours. You just didn't know that it was there. And then from there, you can look and see what other assets are attached to the one that you just found. So that's the kind of thing that the researchers do, and the uplift from them doing that is phenomenal. We've seen engagements where the difference between automation and then when the researchers have come in and started to apply creativity to it, add a 62% delta to the number of discovered assets as part of that process. And you can see the list of reasons why that happens on the side here. Shadow IT, which I've mentioned before, Forgotten, which is the legacy IT problem. From a risk standpoint, unpatched systems and obviously abandoned systems, they all contribute to this issue of attack surface that you don't know about. I think collectively, standalone, but also collectively, we're able to make that the gap between the graph that the defender has and the gap between the attacker graph a whole lot tighter.
So what do we need to do as an industry, as a culture of InfoSec? We have this 1, 2, 3, accept, find, and know. First and foremost, we must stop ignoring unknown attack surface. We all know, we all agree that asset inventory is the first step, if not step 0 in any information security program. We must know what it is that we're meant to secure.
Yes.
Who can argue against that? So I think the only reason we ignored it in the past is because we didn't have technological solutions that were any good at finding asset inventory. That time has passed. They are now very good tools to help this problem. So second, after you go, okay, asset inventory is a problem, we should solve it, is to know where your assets are. What are these assets? Are they websites? Are they mail servers, DNS servers? And everything about them, all the metadata, the type of software that they're running, everything, what country that they're in, all the metadata. And number 3, you want to know what they're worth. Not every asset is equal, and not every asset is managed by the same person or set of people. So you want to know the responsible party. So when something in an asset is detected, there's a website there, it has an unpatched Tomcat vulnerability, who's responsible for that? So every asset, you need to know where the asset is, what it's made out of, and who's responsible for it. Very simple. That's what we need to do.
Absolutely. And I think, Jay, your call out at the beginning there, you're absolutely right. The whole idea of like knowing knowing what your assets are is step zero of risk management 101, and it has been forever. I think really what we're seeing with these new solutions and the need for them is that how you do that has evolved. I think the time when everything was behind a firewall and a block of IP addresses, and that was really the end of the story. That inventory was mostly done inside the perimeter of a network. Now it incorporates the cloud, acquisitions that have been made, all of those different things. So the nature of the problem set and the solutions that are required has actually shifted over time. And really, that whole idea of accepting and ceasing to ignore unknown attack surface, it's one of those things where we're seeing this as I think we've both said at this point, as the data that Jer pointed out before. This is a problem that everyone has, literally. Like if you go looking for it, you will find it, and it will surprise you. So you're just basically accepting the truth of that, and then getting on with, okay, well, how are we going to start to find out where that exists, and then know what the next steps to take look like. So speaking of having a look at stuff, here's the analysis that we talked about at the beginning of the webinar. So essentially, we've got a link here and a promo code that you can put in. We'll switch to Q&A in a second, but we'll just leave this up here for a second. It will actually be on the question slide as well. So I think
I'm actually really excited about being able to offer this. Casey and I both believe that everyone should have an asset inventory. And what this is you fill out the link, put in the code. We'll show you BitDiscovery, we're running through it, and we'll give you an inventory on your organization, free.
Yep.
Come and get it. We want everybody to have this. We want everybody to have an inventory and know what they own, at least today.
Absolutely.
Okay, so thank you guys both so much. That was hugely valuable. Lots of good conversation there. We did have a couple questions come in already, actually, which is great. And as I'm reading through a couple of these, would love to just see if anybody else has any more that we haven't gotten to, or anything that was unclear that they'd like more information about. Starting first, we actually got a question pretty early about the topic of attribution. So the asker was summarizing that attribution is often very difficult to do, and they were curious how Bugcrowd and BitDiscovery are able to conquer that, specifically with asset inventory and asset risk as well. So maybe over to Jeremiah first.
So I mentioned one of the techniques we can use Whois in a lot of cases to find assets that are related to other assets. If you tell me this domain name and these assets are owned by this organization, then they probably own those other things, because Whois tells us about that connection. It's certainly not the only way. There's a bunch of other ways that BitDiscovery can use. One of which, just as a quick example that comes to mind, is let's say Google AdSense widgets. When you put a widget in a website, like a Google code, LinkedIn, Twitter, whatever, a lot of times they'll have a unique identifier. So if you say, I'm interested in this asset, which has this AdSense code, show me every other website on the internet that has a website using the exact same code, because they're probably attributed, related. So you can actually stack up a bunch of these techniques and build up confidence on related assets on the internet. It's never going to be perfect. You will miss things. And that's where Casey and the Bugcrowd team come in to find the things that automation can't put together to find attributed or related assets.
That's great.
Yeah.
Casey, did you want to add anything?
No, I think Jer covered that off pretty comprehensively. That was good.
Great. Okay, so then the next question, Jer, since you're on a roll already, how do you keep the inventory and asset inventory actually updated and fresh?
There's a couple answers there. One is we're constantly mining the internet in general, constantly taking in data about the internet and on all the assets on it all the time. For every column of data, it's about 115 or so, 150 or so per asset. They come in from the third parties at different frequencies. Some we get every day or two, some we get every 30 days or so. So it really depends. I would say safely, the metadata about every asset is out of date, probably no more than 30 to 45 days. That's about the benchmark. What we're working towards for all the assets that are currently in someone's or a user's inventory, we want want to get everything updated every 24 to 48 hours. So that's what we're working towards. So right now, 30 to 45 day lag is what's common.
Perfect. Okay. I think probably the last question that we're going to get to, I don't think we're going to have a chance to get to a few others, but I will reach out to those individuals because I think they are good questions. And then the one here is just clarifying the difference again between asset inventory and asset risk. Do you need both of them to kind of operate together? What does that look like?
Go ahead, Casey, you can take that one.
Yeah, sure, I can take that one. Yeah, so asset inventory is the product that's powered by BitDiscovery. Asset risk is the product that engages with the research community to do the parts that they do. So, really, I think the functional difference for a user is asset inventory is really focused around, the pivots that you can do around the management side of things. Asset risk is about digging in and creating prioritization and the sorts of risk-focused information that an attacker's mindset can provide to this particular problem. Asset inventory operates on a continuous basis. Asset risk at this point in time is a project-based deliverable. Yeah, so I think that's really the summary of the differences between them from my perspective. They do work together really well in concert because obviously the things that the hunters find, that can be fed back in to generate more information, and also vice versa. I think the use of automation to get hunters on target more quickly, I think that's pretty powerful as well. So there is a complement there, but they also do stand alone.
Great. Thank you so much, Casey. And I'm sorry, I did actually get one additional one that I think is probably pretty important to answer. It might have come from somebody who's in the hacker community or might be a recon person themselves,
Sure.
asking about, does the product undermine bug bounty hunters? Because typically hunters are incentivized by finding vulnerabilities, whereas asset risk, I think they probably noted, is more about finding the assets themselves. So can you speak to that a little bit, Casey?
Yeah, for sure. That's a really good question. What it does is it actually gives it nets out to more attack surface for the bounty hunters to go after in a bug bounty context where they're actually looking for the vulnerabilities. So I think that's one part of it where it actually helps. I think in terms of the recon hunters that are brought into asset risk, they are rewarded for excellence in recon skills under a bug bounty like reward model. So there's a component there where that's happening for them as well. And I think from a technology standpoint, if the question's more around asset inventory and the BitDiscovery side of things, recon really burst onto the bounty hunting scene 3 or 4 years ago as the hotness and the ability, the facilitator rather, for people to clean up quickly and to do some really good work. At this point, it's pretty conventional wisdom in terms of the particular types of techniques that different bounty hunters use to actually have recon be a part of their workflow. So at this point, it is at a point where, platforms that are actually consolidating some of that knowledge, doing additional things like what BitDiscovery are doing and creating this enormous database that you can search through really quickly to find that. I don't see that as undermining them. If anything, we're trying to create more opportunity.
Fantastic. Thank you so much for answering that last question there. For any more that have come in, again, I'm going to have to reach out to you individually because we are at time now. But honestly, thank you both so much, Jeremiah and Casey, and thank you everybody that attended and stayed with us for so long. I know that it's, schedules are tight right now with a lot of webinars going on, so we do definitely appreciate your time and attention. Thank you so much.
Absolutely. Thank you.